Okay, so this is the last problem in this series, and again we are looking at a shell, explosive shell, which is initially stationary and which splits into three parts. Instead of writing the problem in words, I'll just show it with a diagram. So my shell is initially stationary, and I also want to show the direction as well. So this is my north direction, and the first piece goes here at an angle of 30 degree. So this is basically east 30 degree north, and the mass is 2 kilogram and velocity is 6 meter per second. The second part goes like this, and this is 20 degrees here, and mass is 3 kilogram and its velocity is 4 meter per second. The third piece obviously will go in that direction, and the mass is 1.5 kilogram and V3 is what we need to find. Okay, so just like the previous question here as well, because the shell was initially stationary, the final momentum, so initial momentum is 0 and the final momentum will also be 0 because it is an isolated system, and we can make use of the principle of conservation of momentum. So I'll skip first few steps and I'll just write like this, and that equal to 0, and again I can write that P1 plus P2 plus P3 equals to 0. That gives us that P3 is equals to minus of P1 plus P2. So the problem basically is just like the previous example, previous question problem in the previous video. We need to find the vector sum of momentum P1 and P2, and then we need to reverse that to get our P3. Now this can be slightly complicated because the P1 and P2 are not at 90 degree. So I will draw the diagram here, starting from this point. Let me see. So this is, I first draw the P1. Okay, let me just write P1 as well. Calculate the P1 here. P1 is 2 times 6 Newton second, which gives you 12 Newton second, and the direction is east 30 degree north, and P2 is equals to 3 into 4 Newton second, which is again 12 Newton seconds, and the direction is south 20 degree west. So let me draw the diagram here. I'll draw a biggest diagram here. So first I will draw the P1. P1 is with this east-west line. I mean, this where I'll get the angle from. So largest diagram. So this length is 12. That's my P1, and that angle is 30 degree. Now P2 makes an angle of 20 degree with the south here. So I need to draw north-south line here for reference, and here it will go 20 degree like this. That's 20 degree. We can just see it from the diagram here. This angle is 20 degree, and this is my P2. The length again is 12. So if you add these two vectors, we end up with this, and this is my vector P1 plus P2. Right, so it's an isosceles triangle. In this triangle, we'll need to find this angle first, which is pretty straightforward. Let me draw this north-south line here. Because this angle is 30, so that angle will have to be 60. Now this north-south line here, this north-south line and this north-south line, they are parallel, and because this angle is 60, then the total angle here, all that has to be 60 as well. Let me show you what I mean. If this angle and that angle, they are I don't know what to call them. We call them alternate angles. So if this angle is 60, that angle will have to be 62. So this whole angle here from here to here is 60, and therefore, and because this is 20, so that remaining angle has to be 40. So let me clean this. Draw it again. Because this angle is 20, so that angle will be 40. So that together they are equal to 60, and we got 60 here. Now in this, because this is isosceles triangle in which this side and that side are equal, their opposite angles has to be equal as well. So this angle and that angle, they have to be equal in this triangle. And because this is 40, total is 180. So these two together are 140. Divided by 2, each of them is 70 degrees. Now if you look at this, this angle is 70 here, and that is 40. So this angle has to be, this angle is 30. So that angle has to be 40 degree. So we have, in a way, we have found the direction of P1 and P2. I mean, we can see that this is our east direction. So direction of P1, vector P1, P2 is, this is my P1 and P2. So direction of P1 and P2 is from east, we are going 40 degrees towards south. Simple. Now all we need to do is we need to find the length of this side of the triangle, this side, P1 plus P2. As we have done earlier, this is isosceles triangle, so we can draw up a perpendicular from here, and the perpendicular will bisect it in this P1, P2 into two equal parts. So let me just call this O, this is A, this is B, and let me call that N. So in this triangle A and ABN, this triangle, I mean that left one half of this triangle, I'm talking about this triangle here, we can find that cos 70 is equals to BN over AB, which is equals to BN over 12. That gives me BN is equals to 12 cos 70, which I will just use calculator and find as 4.104, and that gives me OB, which is my P1 plus P2. Magnitude of P1 plus P2 is twice of this. Alright, so that becomes 8.208 Newton second. Let me enclose that in a box, because you people would say that I'm not writing from left to right, so I'll just close that in a box, just to say that it's something which I have done separately. So that gives me that P1 plus P2 is equals to, I'll write the complete description of P1 or P2 here, P1 plus P2, because I have the direction as well now. This is the direction that we found. So P1 plus P2 is equals to 8.208 Newton second, and the direction is east 40 degrees south, and therefore my P3 is equals to minus of P1 plus P2 as already written here. That gives you minus of 8.208 Newton second east 40 degrees south. That gives us 8.208 Newton seconds, and I just need to reverse this vector, this direction, and we already know how to do this. I'll replace east with west and south with north, so that becomes west 40 degrees north. That's my P3. I just need to now find the velocity. My P3 is, as we already saw, it is 1.5 kilogram. M3 mass is 1.5 kilograms, so 1.5 times V3 is equals to 8.208 Newton second, west 40 degree north, dividing both sides by 1.5, and this is my velocity, west 40 degree north, and I kept that as, sorry, not Newton second, this is velocity now, so meter per second, west 40 degree north. That's the velocity of the third part.